Hello everyone, we are going to talk about simplifying some of these sum and difference formulas, but we're going to do it now where they're not necessarily on the unit circle. So when we do these problems, I'm going to use helper triangles to help me find missing sides, and we're going to use a lot of the ideas that we've done this semester and kind of put them together in one problem. They look kind of intimidating, but you have the formula right here. You've done most of these things. You'll get used to this pretty quick. Let's try one. So first it says, given that sine of A, that's opposite over hypotenuse, is 2 over radical 13, and the cosine of B, adjacent hypotenuse, is 1 over radical 5, and they're both in quadrant 1, okay? So we don't need to worry about anything being negative. Find the exact value of the sine of A minus B. Now, we're not going to actually figure out what angle B and what angle A are. I don't really care. I don't need to know what they actually are, but what I am going to have to do is figure out the missing sides, because to do sine of A minus B, I'm going to need to use that formula. So I need to know the sine and the cosines. So first, let's find the missing sides for our triangle. And we've done this idea before. If you tell me that the sine of A is 2 over radical 13, then opposite over hypotenuse is 2 over radical 13. And I'm going to label that angle A. Okay? I'm going to do the same thing for cosine of B. I'm going to draw just a helper triangle and say this is B, and the cosine of B is 1 over radical 5. That's adjacent over hypotenuse. So the first thing we need to do is, let's do some Pythagorean theorem here, and we're going to say, I'll just call this like x. So x squared plus 2 squared is radical 13 squared. Well, that would be x squared plus 4, and when you square a radical, you just get the radicand. X squared is 9, so x is 3. Now I have the missing side there. I'll do the same thing here. 1 squared plus, I'll just call it y, is radical 5 squared. 1, that's just 1, plus y squared is 5, and then y squared is 4 if you subtract 1, so y is 2. Okay, now I have the triangles that I need. I'm just going to kind of move this out of the way because I don't really need this work anymore. I can even shrink it. There you go. Okay, so there's all that Pythag stuff. But now I'm going to actually figure out what the sine of A minus B is. And remember, there's a property. The sine of A minus B, you have to expand it, and it's right here. So I'll say that's the sine of A times the cosine of B. So A and B. And then minus the cosine of A times the sine of B. So we need to find the sine of A, the cosine of B, the cosine of A, the sine of B. Well, we have the triangles right there, so we just got to fill in the blanks. What is the sine of A? The sine of A is opposite over hypotenuse, so 2 over radical 13. What is the cosine of B? Adjacent over hypotenuse, 1 over radical 5. That was given to me. Minus, what is the cosine of A? 3 over radical 13. What is the sine of B? 2 over radical 5. Now the nice thing about these problems, when this works out, is you already have a common denominator. It's radical 5 times radical 13. Well, those are both under the radical, so you just multiply 5 times 13 and get 65. And in the top, I have 2 times 1 is 2, and 3 times 2 is 6, so 2 minus 6. I'll just write this as negative 4 over radical 65. And like we've been doing all semester, you just got to rationalize that. That's not a big deal, so give them a buddy. And you have negative 4 radical 65 over 65. Now, you should look to see if this fraction reduces or that radical can reduce, but since neither of them do, we are finished. It's negative 4 radical 65 all over 65. So you're essentially going to have to do Pythagorean theorem twice, and then you're going to have to use those helper triangles to evaluate some things. This arithmetic shouldn't be too terribly difficult most of the time, but we'll see that sometimes you have a little bit more to do. So let's try another one. I'll keep those formulas up there, but I'm going to draw 2 helper triangles, and we'll see how this goes. So I'm just going to copy that. There you go. Okay. The sine of x, so that's x, is 3/5. Now I can do this one in my head. That's a Pythagorean triple. That's 4. The tangent of y is 1 over radical 15. So for Pythagorean theorem, we don't know the hypotenuse this time, so just be careful. We'll just call that like c squared. 15 plus 1 is 16. 16 is c squared, so this must be 4. So now I have everything I need to be able to do this. I just need to use the right property. The cosine of x plus y, that's right there. So I'll write it out just to be safe. The cosine of x plus y is the cosine of x times the cosine of y minus the sine of x times the sine of y. Be careful, the addition formula has a minus in it. So that's a little different than the sine formulas. So now we just got to fill in the blanks. The cosine of x is 4/5. The cosine of y is radical 15 over 4. The sine of x is 3/5. And the sine of y is 1/4. So we kind of got lucky again. The denominator is 4 times 5 in both of them, so that's 20. And in the top, I have 4 radical 15 minus 3 times 1 is just 3. And that looks pretty messy, but you don't have any like terms in the top. And like 3 doesn't even go into 20, so I'm not really able to clean this up very much. You can't simplify the radical. You don't have a radical in the denominator. That is your best answer. Okay, it's messy, but that's okay. It can be messy. All right, let's try a couple more. So we might have some radicals that need to get simplified in these two. So let's draw my helper triangle first for A and B. Okay, there's one. Okay. So I'll say the sine of A and then sine of B. Again, you're in the first quadrant, so you don't need to worry about negatives. The sine of A is 3 over radical 10. The sine of B is 2 over radical 5. So I'll do it over here. X squared plus 3 squared is radical 10. X squared plus 9 is 10, so x squared is 1. That means that's 1. And then I'll do the same thing. X squared plus 2 squared is radical 5 squared. X squared plus 4 is 5, so x squared is 1. Again, they're both 1. Fine. Doesn't really matter to me. Now I'm going to use the sine of A plus B formula. So the sine sum formula is right there. Again, I think it's good practice to write it. The sine of A plus B expands into the sine of A, the cosine of B, plus the cosine of A times the sine of B. Now I just need to figure out all those things. So the sine of A is 3 over radical 10. The sine of B is 2 over radical 5. The cosine of A is 1 over radical 10. And the sine of B, the cosine of B is, the sine of A is 3 over radical 10. The cosine of B is 1 over radical 5. I got to be careful. This sine cosine. So cosine is adjacent to right by it. So this cosine of A is 1 over radical 10. The sine of B is 2 over radical 5. Okay, so just be careful because I kind of got an autopilot there. That's a cosine. Sine, cosine, cosine, sine. Maybe make sure cosine of A, 1 over radical 10, sine of B. Yeah, we're good. Okay, and hey, look, we got a common denominator of radical 50. Now, that's going to have to get simplified, but I'm going to come back to that. In the top, I have 3 plus 2, which is 5 over radical 50. Now, 5 over radical 50, I can do a couple things. First thing I can do is rationalize this by giving him a buddy. So it's 5 radical 50 over 50. But one thing you can do is simplify 5 over 50. That's 1 over 10. But the other thing you can do is, remember 50 is 5 times 10, which is 5 times 2. So 5 times 5 times 2 is 5 radical 2 over 10. And that actually simplifies again because 5 over 10 is 1/2. So this is radical 2. The whole thing comes out to radical 2 over 2. So if you want the completely simplified answer, you got to go a little bit further in that one. And that's why sometimes it'll say you have to simplify a radical. In this one, I did have to simplify a radical, and I ended up reducing some fractions. Okay, so radical 2 over 2 is your final and most simplified answer. And we've seen that a bunch this semester. All right, we'll do one more. So let's see if we can draw our triangles. Again, we're in the first quadrant. That's nice. So, okay. if you say that the cosine of A is radical 22 over 6 and the cosine of B is radical 2 over 2, actually that's a 45, 90, but I'm just going to pretend like I didn't notice that. So radical 22 squared plus, I'll call it y for now, is 6 squared. 22 plus y squared is 36. I'm just going to leave that as radical 14. That doesn't simplify anyway. So this is radical 14. If I do radical 2 squared plus y squared, 2 plus y squared is 4, y squared is 2, so this is radical 2. Okay, so that's all my Pythag work. I don't really need that. I guess it doesn't really matter. Cosine of A minus B, so I can see the formula there. Cosine of A minus B, I'm using this formula, is the cosine of A times the cosine of B plus the sine of A times the sine of B. So let's find all those things. Cosine of A, radical 22 over 6. Cosine of B, radical 2 over 2. Sine of A is radical 14 over 6. Sine of B is radical 2 over 2. We got a common denominator, 12. Now, to simplify that, I could do 44 and make a factor tree, but I know I'm going to have to break it down, so let's work smarter, not harder. 22 is 11 times 2, and then I have to multiply that by 2. And 14 is 7 times 2, and I have to multiply that by 2. So I kind of did that in my head just to make it easy, because now I can say this is 2 radical 11 plus 2 radical 7 over 12, and that's your best answer. You could probably, like, do this if you wanted, because 2 over 12 is 1/6, but I'm just going to leave it alone, okay? Maybe you could even think of it like this. Factor out the 2. Radical 11 plus radical 7. That's probably the best answer, actually, because you can factor out that 2. But this will work as well. I don't think Delta Math really cares which one you do. I would consider this to be the most simplified, though. But so for the most part, it's just a matter of can you work with radicals and can you simplify some fractions. We have done these helper triangles quite a bit this semester, so that should be a good review. So go ahead, give your Delta Math a shot, and maybe hit that like and subscribe.